Alright, in this video we're going to solve logarithmic equations. So it says solve the log of 2x minus 1 equals to 2. So what number do I put in there so that when I take 10 and I take the log of this number, base 10, I get 2. Well, the first step is to make sure that you have the log isolated. So is there only one log here, and is it by itself? Yes, it is, right? We've done that. So log base 10 of 2x minus 1 is isolated all by itself. It's equal to 2. Alright, then now we're in log, so we're going to change to exponential here to solve this one. The base is 10, remember? 10 raised to the power of 2 equals, remember, inside, right? That's how you change. That's back to the first section of logarithms. So 10 squared equals 2x minus 1, right? And now this is a pretty easy problem to solve. It's just a linear problem. So 100 equals 2x minus 1. Add 1 to both sides, right? 101 equals 2x. Divide both sides by 2. And our answer is 101 divided by 2 equals x. And that's the exact answer and the approximate answer all right there. You don't need to change the decimal. That's fine right there, right? Doesn't reduce, so we can get the exact answer. If you put 101 divided by 2 in here, you will get an answer of 2. Watch. So let's just show that. Log 2 times 101 divided by 2. Whoops. Gotta get the minus 1 in there. Minus 1 equals 2. Alright, well what's this come out to be right here? This portion? Well, the 2's cancel, right? So they actually go away. So this is 101 then. So what's 101 minus 1? Well, that's 100. Now the question says, is 10 to the second power 100? Yes. So it checks out. That's what x has to be for that statement to be true. Okay, let's try another one. Now again, if you have one single logarithm like we do, we need to isolate this single log from here to here. It needs to be by itself in order to be before we can change it. So you should be able to see the things that we need to get rid of, right? So first step, subtract the 2. That's 2 log base 3 of x minus 3. And then now you can do two things. You can put the 2 up, which is a reverse power rule. But if it's 2 times, I might as well just divide by it. Divide by 2 like that. Divide by 2 on both sides. And I have the log base 3 of x minus 3 equals 1 now. See? The log is by itself. I'm stuck. I don't know what to do. Oh wait, I got to get in here. So change to exponential, right? 3 to the first. And that unlocks it. 3 to the first gives me x minus 3. And look at how easy it is to finish it off now. Add 3 to both sides, and you're done. 6 equals x, and it's the exact answer. So anytime you get stuck, think about changing to the next form. You know, if you're in log, try to change to exponential. If you're in exponential, try to change to log or take the log of both sides. So 6 works in here. We can quickly put that in and see how that would work as well. Alright, let's try another one here. It's slightly different. This one has more than one log. Now if you have more than one log, you're going to have to bring up some other properties. Remember those product rule properties? Things are being added together. You can actually create the multiplication of the logs, right? So since we have the same bases, 4, I can rewrite this portion as log base 4 of 3 times x plus 1 like this. See? The product of these two values, right, equals the log base 4 of 2x plus 3. Now there's options here. My options are that I could get the logs on the both sides and use another property. But just look at this for a moment. If you have the log of this stuff right here, right, the log of this mess, and then over here you have the log with the same base of this mess, aren't those messes equal to each other? Right? They have to be. The input here has to be equal to the input here if you're going to take the log base 4 of it. So why don't I just say that 3 times the quantity x plus 1 should equal 2x plus 3. So I'm saying that what's inside here has to equal what's inside there, right? Because they're both logs. So then now, look, I'm to an easy equation. Distribute the 3, right? 3x plus 3 equals 2x plus 3. Subtract 2x on both sides. That'll be x plus 3 equals 3. Subtract 3 on both sides. And my answer, x is equal to 0. And let's check this one because that's kind of a nice answer, isn't it? If I put 0 in here, I get the log base 4 of 1, right? Plus the log base 4 of 3, and that is supposed to equal the log base 4 of 3, right? When you put 0 here. Well, what's this? 4 raised to what power is 1? That's just 0 in itself, and then look, they're equal. So that's the answer. X is 0. That makes that true. Okay, now I've given you kind of a little tricky one here, but try to see if you can solve this. It's kind of like the last one I just did, right? Notice it's got some natural logs to make it trickier, but that shouldn't change anything. See what you can do. Pause it and try it. Okay? Alright, so a couple options. Remember, you're trying to get at the x, and right now I have 2 logs, so I can't solve for one of them. I got to get them together. I need to get rid of this 2 because it can't stay out front, so I need to put it back up. Okay, so that becomes natural log of x squared equals the natural log of x plus 6, right? Now look, I'm in that same situation. I have a natural log of something and a natural log of something on either side of the equal sign. So it says that this and this have to be equal to each other. Okay, but now I have a quadratic. So in order to solve a quadratic, I need to get them on the same side. So I'm going to subtract an x and subtract a 6. And then see if they factor, which they probably do. These look like nice ones, right? What two numbers multiply to negative 6 but add up to negative 1? Negative 3 and positive 2 do? Yep. So my two answers are 3 and negative 2. But don't be so fast to say that those are your two answers, because remember, logarithms can only have positive inputs, right? So here was the original equation, so I can only have a positive input into here, okay? I mean, positive in the sense that when I take the log of it, it has to be positive. So negative 2 will work here. Negative 2 plus 6, I get 4, but negative 2 will not work here. It has to work in the original and before the manipulation. So here we can't take this one, and we can only use this one as our answer. Okay, so we just have x equals 3 is the answer for this one.